Hi, today we would like to talk with you about modern application lifecycle. My name is Kobi, I'm from VMware Tanzu.
Hello, I'm Oded from VMware Tanzu.
Hey,
Kobi.
So it's no secret and it's no news that enterprise companies and our customer is pushing for modern application development,
Sure.
usually driven by a modern architecture like microservices, which eventually landing on top containers.
That's correct. And from the end user's goal, he sees the user interface or he sees an API. But to get a production-ready environment that the user can use, he needs a company that can deploy much more frequently. He needs to have a better deployment lead time. And those companies need a better mean time to recover if there are any issues with an application in production. So we need to really think about how do we get a modern application lifecycle going for those end users.
I think that we will have to call it, how do we get from concept to production in a secured, fast way?
Exactly. So let's talk about the developer environment first. So the developers, when they are developing their application, the development teams usually begin with a local Kubernetes environment. They would use modern frameworks, maybe Spring, maybe .NET Core, and they will do some testing internally to verify that everything works as expected. Now, at some point, they will commit their code to a Git repository or something like that, and eventually they would expect a CI pipeline to take their code and run it on a target container. Now, the main question is, how am I going to take this application and take it from the developer's laptop and move it into a production-ready image? So the main question is, how do I get automated builds from my applications, right? I want automated images. I want them to be secured. I want them to be reproducible. And I want to make sure that every time there's a security vulnerability, I can just immediately apply patches and make sure that all of my images are secured and up to date, right? That's the most important thing from the developer's perspective.
And currently, developers spending a lot of time building those images, right?
That's correct. That's almost, I believe, like 60% of the developer's time is spent on non-functional requirements, things that they need to do in order to just make sure their application actually runs.
Okay, so maybe improving it by 10% can be meaningful things.
Indeed.
So this is the custom application code that we develop inside the organization, right?
Correct.
But what about those data services like databases, message brokers, cache layers that we want to take from the public repositories and take inside our organization? So those also open source, but we don't know who developed them, we don't know who contribute them, we don't know if they're secured, and who is maintaining them while they're running inside our application, inside our organization.
Exactly.
So I think that we need some kind of secured catalog, but still open source, right?
That's
that
correct.
Developer can consume services, that developer can rely on, right? And they can choose their data services to use their application.
That's
and
correct.
so while we have our custom code building automatic, as you explained, and while we have the secured, robust catalog inside our organization, we will need some kind of image registry that both of the images / Helm charts in the case of catalogs can be reside on. So the developer can take it from a secured registry with minimum time and maximum reliability on that images.
Exactly.
So I think that this side, right, closes the continuous integration of the application lifecycle. But how do I take it into a deployment?
That's correct, Kobi. So we solved the part that talks about creating our images. Our containers are ready for deployment. But how do we move from this continuous integration into a continuous deployment? So when we talk about continuous deployment in a modern architecture, we of course talk about Kubernetes, right? And when we talk about Kubernetes, we want to make sure that it is open source, upstream, vanilla Kubernetes, that is not forked in any way, that any changes that you gain from the open source contributions of the community, you will also gain on your on-prem environment in your private cloud or on the public cloud, of course. So we want to make sure that we have an upstream certified distribution.
So there is any advantage about taking this Kubernetes distribution from a vendor?
Absolutely. So when you're at an enterprise, You want to make sure that your distribution is conformant, that it's been tested and validated for enterprise readiness. And of course, if you have any issues, you want to have support. And you also want to have like automated tools such as automatically scaling up, scaling down, security patching without any downtime. All of these things need an enterprise-ready distribution. Now, you will probably begin with one or two clusters, but very soon you're going to have multiple clusters. You're going to have a point where you have clusters maybe on-prem, and you're going to have clusters in the public cloud. Maybe there will be different distributions, different versions. And the question arises, how do you manage all of these different distributions, and how do you apply all of your enterprise readiness and your robust access control and all of your policies that your organization expects when you reach this multi-cluster environment?
So I think this is a good point, and this is a true challenge. We see it all over our customers. They're starting from one Kubernetes cluster, and soon they are getting with a few on-premises, few on the public clouds, and many times we see it with the different distributions of Kubernetes. And here you're correct. We need some kind of control plane, okay? Central control plane that can manage all those Kubernetes clusters from a single place, that it can have role-based access control, security policies, whether we are talking about security policies on the Kubernetes itself or a image registry security policy, correct? And also, what about backup and restore? This is something that is really, really important. I want to make sure that I'm backing up all those Kubernetes clusters no matter where they are located, whether it's on the on-premises or whether it's on public cloud. So I do want to have some kind of control plane. And of course, if I'm scaling up. But this is not enough for that, okay? We need a little bit more. So if we are looking at all those images in our Lightboard, we can see that there is the developer side, there is the DevOps side, and of course there's the operator side. And every one of them want to make sure that it gets full observability or about what's going on with their infrastructure or with their application, right? Correct. So we need to manage some kind of a full observability. Starting from the infrastructure below to the container runtime, which in that case it's Kubernetes, and for the application. So we can see from a central place root cause analysis. If there is a problem, we can see the model, the dashboard, and no matter if we are running on the on-premises or if we are running on the public cloud, we can see everything from a single place.
That's correct, Kobi. So observability is definitely important when you talk about multiple clusters. Another thing that's very important is how do I connect multiple clusters to talk to each other in a secured manner? And for that, I want to have a service type solution that will allow me to connect these applications that can be consistent and that can be secured without any risks of exposing my data to unknown third parties. And for that, I want to have something like Istio or something like that, where I can have mutual TLS between my clusters. Usually when we talk about service meshes, it's usually siloed at a single Kubernetes cluster, but I want a solution that allows me to expand between multiple clusters so I can scale out very easily across my different applications.
So does it take care of a cluster that is distributed between sites? I mean, between the on-premises and between the public cloud?
Absolutely. So you can have one cluster running on-premise and another one running on a public cloud vendor's environment, a Kubernetes cluster, and you can communicate between them securely using mutual TLS, and of course control the traffic and perform all kinds of analytics on the traffic that goes on inside your environment.
And I think if I'm looking at all of those components that we put in the Lightboard, I think that the real advantage that I want to make sure that I get inside the organization, that I want to make sure that the tools are open source.
Absolutely.
They are aligned to the open standard, right? Mm-hmm. And I have no vendor lockiness, and I want to make sure that I'm using the tools that enable me to use a multi-cloud solution.
Definitely. You want to make sure that all of your software stack is aligned to the CNCF that is open source and that you can continuously gain the advantages that the community is doing externally. So Kobi, if you're looking at all of these solutions, let's see how VMware Tanzu helps with every one of them. What do you think? So when we're talking about creating automated images without having to write any Docker files, without having to do any manual scanning of our images, we have the Tanzu build service that can help us with this challenge. It's based, again, as you said, on an open source CNCF project called Cloud Native Build Packs. When we're talking about a catalog of enterprise-ready Helm charts, we have the Tanzu application catalog, powered by Bitnami. And that's really to give you a consistent, conformant Helm chart repository that you can consume inside your organization without any concerns.
And I think that most likely if you're going into the public cloud, you will find some kind of services powered by Bitnami as well.
Absolutely, one of the top vendors in this area. Now, eventually you need to put them in some registry, and for that we have Harbor, which is, again, a CNCF project that is open source that you can use to, of course, store your images, but also to scan them for vulnerabilities and to sign them to prevent deployment into a cluster without approval.
So you get a full DevSecOps pipeline.
Exactly. The secured software supply chain is built into these tools. Now, eventually, you're going to run them on Kubernetes, and you want to have the same distribution whether you're running on-prem or you're running in a public cloud for consistency and for conformance. And for that, we have the Tanzu Kubernetes Grid in its various distributions, which can guarantee that you have, again, an upstream-aligned, open-source, vanilla Kubernetes wherever you're running them. Now, when you scale out, you want to have multiple, a management plane, a control plane that is global, that can be managed, be it Tanzu Kubernetes Grid or be it another distribution. It doesn't really matter. And for that, we have Tanzu Mission Control, which allows us to do exactly that. So we can make sure that we always have a conformant, robust access control, data protection, and security policies across the board. Talking about observability. So we want an end-to-end observability from the infrastructure layer all the way up to the application layer, distributed tracing, developer frameworks, etc. And for that, we have Tanzu Observability, which gives us exactly that. So we can guarantee that we have perfect end-to-end root cause analysis if we ever have any issues, so we can do a better mean time to recover. And if you look at the bottom layer, we want to connect our clusters across different Kubernetes distributions. And with that, we can use Tanzu Service Mesh, which would allow us to do exactly that with mutual TLS using a global namespace across different Kubernetes clusters. So I think we have a pretty good picture here. We solved most of the challenges.
Yeah, I think it's a great recap, and I think that VMware Tanzu can assist you with all your modern application lifecycle, right? So when you are starting just from Kubernetes and images, and when you want to take it to the next level with secured pipelines to deployment, and whether if you want to manage it on a multi-clouds, so you can use the Tanzu Mission Control. Thanks a lot for joining us. For more information, take a look at tanzu.vmware.com. Thanks.
Thank you.